Hello, good day everyone and welcome back to the Roy Tech channel. We will continue our discussion in this video regarding the development of our database programming project in C Sharp, particularly in Visual Studio 2022, using at the same time Microsoft SQL Server. I have opened our previous project which we have just pushed to our GitHub repository. It's called DB project, and in our GitHub repository, we have the same exact mirror of the same files. No? We have a backup in GitHub. The next thing that I'd like to discuss is a housekeeping technique like GitHub, no? That prevents us from that will allow us to minimize the complexity of our code. One way to simplify our code is to avoid redundancy. Okay, which means that we do not want to repeat functions, the coding of functions that are used by the different components like forms. No, if a form will use a function during loading time, like a function to connect to a database, we should just have one copy of that function, which is accessible by all forms that will use them or will use it. The moment we use the code or repeat the code in every form, we will be creating a redundancy, which will make it difficult for us to update. Okay? For example, connecting to a database, because if we have redundantly created it in 20 different forms, we also have to edit 20 different times. So the appropriate way is to create a global class that will store global functions, and we can just call that class, rather a function from the class, from the forms that will use them. However, uh, another appropriate technique is the use of a global static class. What is a static class? A static class is different from an ordinary class because ordinary classes require you to declare instances of the class before you are going to use the private functionalities of the class. For example, for you to be able to add integers, you have to declare int x or int x and int y so that you can add x and y. So you have x plus y. However, in C++, there's a static class called math. You don't have to declare math x, for example, no, in order to be able to use round, ceiling, and floor functions. We just call math.round, math.floor, math.ceiling right away. So that's how we are going to create it. We are going to create a static global class that will call all functions that are going to be redundantly used by the different forms or reports that are included in our project. Let us do that now. No? To be able to create a global class, we go to our project. We right click and click add. No? Remember, we go to the project, right click and choose add and click new item. Okay, new item, not a form, not a component, but just a new item. Okay, we have the different choices. We just choose class, just an ordinary class, and we give it a name here below. Okay, it's important that we give it a name already. No, we'll call that global. Okay, we call that global, and then click add. Okay. Now we have this. We'll just remove the unnecessary parts, yet the default parts, and we'll change the internal to static. Okay, okay. Right away, even if you don't use global, okay, specify global, you'll be able to call the functions within the static class. Now, as an example, I'd like to introduce two functions that are used by forms to automatically adjust the size, okay, during runtime to occupy the whole area of the screen. Okay? We'd like to apply that to our main form. So that we don't have to adjust it every now and then. What we need to do is for the main screen to occupy as much space as possible during runtime. In order to do that, we need to make use of two workspaces built in uh, uh, Visual Studio. It's called the system workspace. Okay, by using system.drawing and using system Windows forms, we'll be able to manipulate the size of our screen. I have already written the function. I'm just going to copy them and explain them to you. There are two functions. Now, one is used to set the size of a screen, or rather a form to the screen size, and the other to the desktop size. What's the difference? When we say set size to screen, it will occupy the whole screen, including the taskbar, which we don't like to do. Okay. The other possibility is to set the size of a screen. Okay. Uh, to the desktop size. It uses system information. Here's the code. No. Okay. It will get the working area. The working area is the part without the taskbar. When you say screen, it will occupy the whole screen, even including the taskbar. But when we say working area, it will only include the desktop. So we'd like our main form to occupy the desktop size. Okay. So we now save this. So we have a global function, rather global class, which is static. We can just call it anytime, and then incorporate it in our main design. Okay. We'll go back to our main form and manipulate it in order to occupy the whole screen. Where do we do that? Now, all forms will have an event called form load. Okay, this is the function that is called when the form is loaded from file to your desktop. Okay, so we go to the screen design and we look for an event called form load. There it is, load. Okay, we'll just click this. Okay, and add two main lines. Two main lines. Okay, there it is. No, let me. Okay, this. Okay, we'll say this GL set to desktop size. Why is this called this? Who is this? This is like the construct in C++, which calls the instance, whoever it is, the instance of the class that is being used. In this case, the instance of the main form. So it will call GL set to desktop size, passing itself as the function, rather the parameter, because this is for this form. Okay. Okay. So when you say int left, this is the left of this. When you say int top, this is the top of this. So the top, left, and the width and the height will be adjusted, okay, according to the work area, okay, occupied by the desktop. So let's go to that again. In the form load, we are going to set the size to the desktop by calling the global function in our global static class, and then we'll bring it to front. We'll show you why later because we are going to make a login screen. Now let's run that. There are errors. Okay, so there's a duplication. I'm sorry for that. There's a duplication of the close construct. Anyway, it's a simple error, nothing to worry about. So now our main form occupies the whole screen. Okay, so we have a global function. We have defined a global function set to desktop size. So all forms that we need to occupy the desktop size, we're just going to call the global function in order doing that. Okay, so from time to time, we are going to add functions to the global class. Okay? This will not be the end of the global class. We are going to add functions like encryption of passwords, decryption of passwords, quotation of strings, and then we are also going to add, for example, connection to databases, which repeats. Okay, connection to our database server, which should repeat every now and then. We are going to unify the functions and avoid the redundancies by placing them in our static global class. Okay, before we end, uh, let us update. Let us save all, and then let us update our no, our Git. Let's go to Git and commit our stash. Let's type okay, added. Let's type added, added global static global class. And adjust by form size. Okay, and then where's the plus? Okay, click this everything, and then we commit stage, and then let's push. Okay, let's push. Okay, it's our GitHub desktop. Let's check. Okay. So we have DB project. Okay. Now there's now a global class. Let's open that. So there it is, the global functions. And then let's look at our main form designer or main form. Let's see, yes, this is our ano, and look at the form load. Yes, okay, the update was reflected. So we are now able to create a static global class, which will be a very useful utility as our code grows, because with it we are able to avoid redundancies. I hope you follow. No? In the next video, I'm going to show you how to use image lists and toolbars that will help us simplify uh, setting of images and buttons in our application or in our form. Thanks for watching, and bye for now.